Hello everyone, welcome back to Maths Lab. Today we are going to discuss chapter 5 and up and down and round, which means to connect mathematics with movements we see in everyday life. Up and down means to movement in different directions, like a Ferris wheel or a point moving along a circle. And round refers to circular motion, which objects moving along a circular path, such as a bicycle wheel, merry-go-round, the hands of a clock, the moon revolving around the earth. So the title is not a mathematical formula. It is a creative way of saying we are going to study circle and circular motion. Circle means up and down, which directions like a Ferris wheel, and round means circular motions. So where things move up, down and around a center. So what is circle? A circle is the set of all points in a plane that are at the same distance from a fixed point. The fixed point is called the center and the equal distance is called the radius. First you take a point O. Now you take some other points around O at the same distance. Make sure this set of points are at the equal distance from the fixed point O. Using ruler you can take the measurement. Now you join these all points, you get the circle. Okay. Suppose I am taking a point on the circle here and join this point to the fixed point O. You get the radius. If you take some other points on the same circle and join this point to the fixed point, you get the radius. All radius in the same circles are same because all the points are at the same distance from the fixed point. The fixed point is called the center. So fixed point equals to center. And the equal distance is the radius. So radius. Imagine 20 students standing around a teacher. This is teacher. Teacher is standing at the center. And around the teacher there are 20 students in the playground. That every student stands 5 meters away from the teacher. That means every student to teacher, the distance is 5 meters. So together they form a circle. If you join the hands of the students, because every student's distance from the teacher is 5 meters, so you get the circle. Okay. Let's discuss parts of a circle. Center, fixed point inside the circle. So this is the fixed point and it is denoted by O. And next radius, small r, line segment from the center to the circle. If you take any point on the circle and you can draw a line segment from center, you get the radius, that is denoted by small r. What is diameter? Line segment passing through the center and joining 2 points on the circle. This is the radius. Suppose this is point A on the circle. If you extend this radius on the other side and meet another point on the circle, that is B, then AB is called the diameter and it is denoted by small d. And we can write diameter d equals to 2 into radius, that is r. If radius is given, you have to find out the diameter, then just multiply the radius by 2. If diameter is given, then if you want to find out the radius, then just divide diameter by 2. So you get the diameter also. Now after that, chord. What is chord? Any line segment joining 2 points on the circle. See, any line segment joining 2 points. AB also a chord. But if you take another point here on the circle here, okay, let's name it P and Q. If you join this PQ, you get the chord, one chord. So in this way, so many chords you can create on a same circle. And what is the largest chord? AB, that is diameter, is the largest chord, and it is passing through the center. So two questions they are given. Uh, which is the largest chord? That is, your answer will be diameter. And another type of questions there, which chord is passing through the center? That is also diameter, because diameter AB, which is AB passing through the center of the circle. The largest chord is diameter, and also name any chord which is passing through the center, that is also diameter. So in this way, so many diameters you can create on the same circle. Suppose this is XY. Okay. Now arc. What is arc? A part of the circle's boundary. A part of the circle's boundary. And see, this is the XY is the chord, correct? And this is, if you point out this way, this is the part of a boundary. What is boundary? Actually, the boundary is the circumference of the circle. Got it? This part. Okay, not the inside. Boundary is the circumference of the circle. Okay. So, and what is arc? The a part of circle's boundary. This is whole are boundary, circle's boundary. So, but a x to y, if you go x to y, then this curve boundary is the part of a circle, and this is called the arc. Same way, P to Q, this is the arc. This is called another arc of the same circle. Okay. So, and the circumference, the boundaries of the circle. You know, circumference means the boundary of the circle. This is, and the perimeter of the circles also. Okay. So, not the inside, only the boundary. Later we will discuss about it more. Important fact to remember. A circle is not the filled-in region. Circle is only the boundary. This is the circle. So this is only the boundary. Circle is means the only the boundary, circumference. The circular region. If you're talking about the circular region of this, that is boundary plus the inside. So what is the difference between circle and circular region? Circle means only the boundary, and circular region means the boundary plus the inside. The blue color represents the circle, and blue color plus the gray color represent the circular region. So let's discuss parts of a circle. First one, radius, a line joining the center to any point on the circle. Okay, so this is the O, center of the circle, and if you draw a line on the circle from the center, you get the radius. That is, suppose this is A, then OA equals to radius of the circle, and it is represented by small r. Okay, so O is the center and OA is the radius of the circle. If the length of OA is 5 centimeter, then if you draw other radius on the same circle, suppose this is the other radius OB and another radius if you draw OC, so they are also equals to 5 centimeter. So OB equals to also OC equals to also 5 centimeter. That means the property is every radius of the same circle is equal. Every radius of the same circle is equal. Okay. Diameter, a line passing through the center. Center is here O and joining 2 points on the circle. On the circle, I am taking 2 points A and B. Let's join AO and OB. We get the diameter, that is AB. So AB is the diameter of the circle. Okay, where O is the center. Okay, OA is one of the radius, OB another radius, but AB is the diameter, that is denoted by small d. And we also know that small d equals to 2 into small r. What is small r? Radius. That means diameter equals to 2 multiplied by radius. If radius equals to 6 centimeter, then find the diameter. Diameter equals to 2 into radius, that is 2 into 6, 12 centimeter. Now tell me, does every line joining 2 points on the circle pass through the center? No. Such a line is called chord. A chord is a line segment joining any 2 points on the circle. Example, this is the circle and here on the circle I am taking 2 points A and B. If you join these 2 points, you get a chord. So AB is a chord. So in this way, you can create many chords on the same circle. Now come to the diameter. What is diameter? A line segment which passing through the center of the circle and joining the 2 points on the circle. C and D, 2 points on the circle and O is the center. If you join CO and OD, you get a line segment, that is CD. CD is diameter as well as the chord. So CD is the diameter, also it is the chord. So you can create another chord also. Suppose PQ is the another chord. So what is the important property here? Every diameter is a chord, but every chord is not a diameter. Why? Because diameter passes through the center, while most chords do not. AB do not passes through the center, PQ do not passes through the center, but CD passes through the center plus CD is a diameter. So diameter is the chord, but every chord is not a diameter. So let's write the important property. So the important property is every diameter is a chord, but every chord is not a diameter, because a diameter passes through the center while most chords do not. Arc. Suppose 2 points A and B are on the circle. There are 2 ways to travel from A to B along the boundary. The curved portion is called an arc, and they are 2 types, minor arc and major arc. For example, think of traveling around this circular path. So this is the circular path. Okay. The short path is the minor arc, the long path is the major arc. Let's draw on first a chord. Okay. Suppose A and B, 2 points. So, how you will travel from A to B? There are two ways. One is this way, this curved portion. Okay. You have to travel along the circular path, not inside like that. No, this is wrong. So, along the circular path, you have to travel and reach to B, A to B. Okay. So, this is the shorter distance. So, this short part is called the minor arc. Only this curved portion. Okay. This is the shorter path and this is called minor arc. If we travel the long distance from A to B, along the circular path. So this portion is called, this curved portion, this green curved portion is called the major arc because this is the longer path from A to B. So this is the red color is called the, so this is the minor arc and this green one is called the major arc. Sector. Two radii and the arc between them form a sector. It looks like a slice of pizza and there are two kinds, minor sector and major sector. Let's draw a circle. Okay, and this is the center O. OA is a radius and OB is also a radius. So OA and OB are two radii. And AB, this AB curved portion, this is an arc. So OA and OB, two radii and the arc AB between them to form a sector. So OAB is a sector and there are two kinds, minor sector and major sector. So minor which one? Smallest one, this portion. Okay, this is minor sector. It looks like a slice of pizza. And major sector, the outer part. So this is the major sector. Minor sector, the smallest part, and the major sector, the largest part. So OAB is a sector which is formed with a two radii OA and OB, and AB is an arc. OA and OB are two radii and AB is an arc. Segment. A chord divides the circle into two parts. Each part is called a segment. So, if you draw a circle, this is the chord AB. This chord divides the whole circle into two parts. One is minor and another is major. Okay. So, each part is called a segment. This is the segment and another is the also a segment. This part. Okay. Now, tell me the difference between sector and segment. What is sector? Sector creates by two radii and one arc. It looks like a pizza, correct? But at segment, it's created by a chord. That because a chord divides the circle into two parts. One this one and another is the largest part. So each part is called the segment. The sector formed by two radii, that is the difference, and segment formed by one chord. So what is the difference between sector and segment? Sector formed by two radii and segment formed by one chord. Angles in a circle. There are two kinds of angles. Central angle and angle at the circumference. Central angle, the vertex is at the center. For example, let's draw a circle. This is the center O. Draw two radius, that is OA, and OB is the another radius. So angle AOB is a central angle, where O is the center. Okay. And second is angle at the circumference. The vertex lies on the circle. Let's take another vertex on the circle. Suppose this is P. P is the another vertex. Let's join AP and BP. AP and BP. So APB is an angle at the circumference. APB is to angle at the circumference, because it lies on the another vertex is the vertex of the triangle are lies on the circle. So circumference. Okay. So APB is the angle at the circumference, and AOB is the central angle, where O is the center, where P lies on circle, lies on the circle. So what is the important property? The angle at the center is twice the angle at the circumference, standing on the same arc. If APB equals to angle this APB equals to 40 degree, then AOB equals to twice. What is twice the angle at the circumference? Angle of the circumference is given 40. Then find the angle at the center, that is twice of 80. So 2 into 40 equals to 80 degree. So this is one of the most important theorem in class 9. Equal chords. Suppose two chords have equal length. This is the circle. Okay. Two chords here. Suppose one chord is AB and another chord is suppose CD. Okay. Two chords are equal. If they are equal, then they subtend equal angles at the center. At the center, they subtend this both chords subtend equal angles, and they are at the same distance from the center also. Distance from the center also, the chord are equal. So similarly, equal central angles subtend equal chords. We have to prove these theorems later. So just right now you have to know two chords, if they are equal length, they are subtend equal angles from the center, and they are in the same distance from the center. Similarly, equal central angles, that means equal central angles also subtend equal chords, vice versa. Perpendicular from the center. Suppose we draw a perpendicular from the center to a chord. This is the circle, O is the center, AB is a chord, OM is the perpendicular. This perpendicular OM from the center bisect the chord AB. So bisect means the perpendicular OM divide the chord AB into two equal parts. So you can write if AB equals to suppose 10 centimeter. Okay, and OM perpendicular to AB. Then AM equals to MB, because OM bisect the chord AB by two equal parts. AM equals to MB equals to 10 by 2, 5 centimeter. So this property is frequently used in problems. Tell me which chord is the largest chord? Which chord is passes through the center and giving the maximum possible length? Yes, diameter is the answer. Diameter is the largest chord. So, diameter. Why? Because it passes through the center and giving the maximum possible length. Maximum possible length. Okay. If in exam they ask which is the largest chord? Diameter. Why? Because it passes through the center and giving the maximum possible length. Two circles having the same radius are called equal circles or congruent circles. If one circle has radius 5 centimeter and another has radius 5 centimeter, then they are called equal circles or congruent circles. Suppose in the first circle, the radius is 5 centimeter. Okay, OA is 5 centimeter. In the second circle, the radius is OB 5 centimeter. Then since OA equals to OB equals to 5 centimeter, therefore the given two circles are equal circles. Okay, or congruent circles. Two or more circles having the same center but different radius are called concentric circles. For example, a dartboard or the rings around a target. Let's draw a circle whose center is O. Let's draw another circle whose center is same O. So you can create more circles with the same center. Okay, but their radius are different. The smaller circle radius suppose 1 centimeter. Okay, and the next bigger circle, it is the suppose 2 centimeter like that. And the third one of the circle, the radius, it would be maybe 3 centimeter or 3.5 centimeter like that. But the common thing is their center is same. So they are called concentric circles. Its radius is different but the center is same.